All right, lap 6. So first of all, actually, my apologies. I somehow uh, forgot about this particular lab. I thought I graded this lab, but then actually it turned out I haven't graded this lab. So it's my apology for getting this to you a little bit late. And this particular lab is essentially an extension of what I introduced to you in the lecture about about consuming a web API. And instead of the humidity value, now I'm asking you to do something a little different. Um, so in this case, is the cloudiness. Basically, the cloudiness value is a similar to humidity, is a percentage, and that value is in that JSON, basically the clouds all field. Now, I've uh, I've actually uh, given you instructions about sort of reading the documentation for the particular API. So first of all, the API you need to use is the API by zip code. Get the current weather data by zip code, so you can find that um, by zip code. So this is you search basically get the weather information for a particular area based on zip code. Then the actual documentation for the JSON document, as you'll see, the cloudiness value is actually inside the clouds all field, and it's actually documented right here, cloudiness percentage. So so when you get the assignment, when I said this is about cloudiness, you need to read the documentation of the API. This is really part of the exercise. When you use a third-party API, you got to read their documentation. Okay. So that's where you get the cloudiness value, which is a percentage, just like humidity. I've shown you how to convert that to the number of LEDs you want to display in a particular color. So it's very much similar to what I've already shown you, and only asking you to do a little bit different. And I want you to use the white color to represent the uh, portion of the LED that shows the cloudiness, just because the cloud is white and the sky is blue. So I ask you the blue for the rest of the space. So for each row, if you really imagine, if you're familiar with a bar diagram, a bar chart, okay, a bar chart turned 90 degrees. Every row is a bar, and the white is actually in white color. And the white color, the length of that indicates how much cloud is there in terms of percentage. Okay, so the method of calculating the number of LEDs in white, which represents the cloud, is essentially you get a percentage converted to number of columns is there. Basically, right now is 8. And this is the same mechanism I've already shown you in class. So there's not a whole lot of that's different. Now, one thing, minor things I want to mention that some of you even try to even modify a variable with all caps. The variable with all caps, there are constant variables. As I said, Python is a naming convention-based language. The Python interpreter doesn't really enforce that. So by convention, if it's all caps, there is a constant. You're not supposed to modify it. This is a constant variable, so you use this as a constant. You only read, you don't write. Okay, just some of those things I want to mention as you do your Python programming. So this is really all there is to it. And maybe you haven't noticed, I have also have this actually displayed on a well, actually, let me first of all let me run this thing to see this in the emulator first. Now, as you know, to run this, you need the API key environment variable, and you know how to set it, right? Um, now, you also know there's a second method to read the environment variables to basically use the environment variables in your Python program. That is the .env, using the .env library. So you can read that .env file. So that's basically the method I use in the week 7. So the one after this. So this is the simple method where you can expose your API key into the environment. You don't need to set this environment variable as a sort of a permanent one. You just need to um, set it temporarily. Okay, it is not meant to be a permanent one. Okay. So this one I just ran, and this is how it shows up here. And then since we already got the real, we got the real sense hat, right? So if you pick up your kit, and then so I want to show you, it's very simple, really. Um, let me see. Hold on a second. So what I have right now, let me stop the share here. You're looking at the Sense hat that's already installed on top of the Pi, and the installation is fairly straightforward. Um, so let me kind of just flip it over so you can take a look. Um, all right, I don't know if you got a good look at this, but it's kind of hard to look because the the lighting is not that great. So the installation is very simple. Now you do want to turn off the power before you put your make any changes to your physical circuit as usual. This is really just precaution not to damage the Pi or any other things. And then you essentially just put install this on top of the Pi. Now the side with LEDs and is obviously facing up, and all the 40 pins, the GPIO pins, they go into the slots at the bottom of the port that's actually on the sense hat. You basically just push it in. In terms of the alignment, basically you align the 4 holes on top of the holes on the Pi. You see the hole, this is a mounting hose. And also the product, the sense hat comes with some screws and plastic risers. And this is meant for if you want to install this permanently and secure it onto your Pi, and then you can use those for those 4 holes, so they can, there's you can have the risers put in between, and then you screw on both sides. But for our purposes, it's not necessary, so I don't think you need to use it. So if you want to install the Pi, the sense hat on the Pi, in this case, you would have to actually take out the ribbon cable, basically the GPL extension cable, and then put on the sense hat. The sense hat, the GPL ports, that basically is a kind of female on both sides, and but you just press this on to the GPL pins, and basically the hat is right on top of the Pi, and the 4 mounting holes are aligned at the corners. The way to look at the sense hat, sort of the right positioning is actually in a way where you will see uh, this little button here is actually the joystick. The joystick is at the bottom right corner. Um, and this is how you position this when you look at the LED screen. And right now you see actually it's flashing because of I think it's because the refresh frequency, the refresh rate of the LED array, the matrix is actually not very high. That's kind of why you're seeing this effect here. At least you can recognize the different colors, and there's, white and then the blue. And it's kind of a little fainted, but somewhat you can make out of the difference a little bit. And if I run, because the weather information actually changes all the time, if I run this, if I run this on the Pi, let's see if it will change the display. It should match. It should match the what we just ran on our emulator. Oh, one thing to mention, actually, there's one thing that did not change is the only thing you need to change once you got it working with the emulator. Now you need to work, make it work with the real thing. You just change this library from sense.emu to sense.hat. That's all you need to do. And then let me run this again. And then let's take a look at see, this shows up. This is the white, this whole first column plus this 3 LEDs, they're white. And this is exactly the same thing you will see in the emulator, okay? So that's what I wanted to show you through this lab, and now I'm going to show you. I just showed you the real sense.hat, and as I mentioned earlier, before we got the real hat, it actually works just the same. The emulator is really, really good, and then the library just makes it work seamlessly. Only thing you need to change is change that library name to sense.hat instead of sense.emu. If you want to try that out, the sense.hat has actually a lot more things on it that we may use that for further experimentation in the future projects. So feel free to play with it. So of course, while you're using the sense.hat, you can't have the fan installed on this. I think the case is not meant for. Now I'm not sure if the case actually I'm using a different case. Just maybe you try it. If the case that comes with the kit is deep enough that allows this to be inside, and then you can actually put on the fan and it had the cover there. But it kind of doesn't make sense because if you are actually installing the sense.hat, then you do want to have this whole surface exposed, and so they can use the controls, the buttons, and the joystick, and look at the LED arrays. Now, because of this, that also means you cannot use the fan like this. So that's so I would say, just use it for short amount of time for your projects. I would not necessarily recommend you running this for a long, long time. I think because the heat that's going to be generated also through the LED as well, it generates quite a bit of heat. So yeah, it will be fine in normal usage, but just kind of probably not. I would not necessarily run this 24/7 like this, right? So again, whenever you make physical changes, you want to take this off and back to your extension ribbon, then you will, make sure you turn off the power, and that's it. That's what I want to show you. So in the previous video, actually, I didn't capture the image of the sense.hat, so my apologies about that. I'm just adding on this little piece here to show you the sense.hat as installed on the Pi. And So yeah, there's a portion of that video when I was speaking, I thought I was showing this sense hat, and actually that was not working properly. So anyway, the quality of this showing this is not that great. I think maybe it looks a little better during the daylight. So unfortunately, it just doesn't look very good. So installation is very simple. Uh, you probably have to take out the ribbon extension cable, right, as you have right now, and then put this on, basically right on top of it, and make sure these four holes at the corner aligned, and don't use too much force. Just kind of be gentle when you push it down. You do push it all the way down though, and when you turn on the Pi, actually this LEDs will actually flash just to indicate, yeah, this is installed. Now, for those of you that didn't follow the I2C portion of the lecture previously because you didn't have that backpack, then that's for actually the LED we worked with before, and the LCD. And in that case, for this to work though, you do need to get the I2C enabled. If you haven't done so, you can go back to that lecture if you need a little refresh on how I2C is working. But if you've already done that before, then this will work without any further changes. Okay, so that it doesn't need the I2C to work.